This is problem 26. It is a homework problem. A, B, C, and E are similar to what we did in 25, but D and F are a little bit tricky, and here's why. If you draw a loop for D and a loop for F that goes through the capacitor, that would be like this for D and like this for F. In every other case, the current flowing through the resistor that's part of our loop is equal to 0. But that's not the case for D and F, because you can draw a second loop for D. Oops, you can't really see that color. So you can draw a second loop like this for D and a second loop like this for F. Current cannot flow through the capacitor when it's fully charged, so you can't have current flowing through here. You can't have current flowing through here. But you can still have current flowing through the purple loop. There's no reason why you couldn't have current flowing through the purple loop. That's similar to what you have here in C. You could have current flowing like that. But see, in C, it wasn't a problem, because if you don't have current flowing through the capacitor, you can't have current flowing through this resistor. But in D and F, you have these resistors here, and for F, this resistor here, which are part of this loop that goes through the capacitor, but you can still have current flowing through them because the current can go through the purple loop. Okay, so you have the change in potential across the capacitor here, and let me call this, well, all the resistors are the same, right? Well, we'll call this resistor 1 and resistor 2, and you can figure this out for homework. And this is V, and this is V. So you're going to use the loop rule for F. You have V is equal to delta V R1 plus delta VC, and in this case, delta V R1 is not equal to 0. When the capacitor is fully charged, it is in fact equal to the current through resistor 1 times the resistance of resistor 1. You have to figure out what that current is. You can do that looking at the purple loop there. Similarly, for loop D, you have V is equal to delta V R1 plus delta VC plus delta VR2, but this is not 0 and this is not 0 because you still have current flowing through these loops. So because the current isn't 0, the potential isn't 0, and that's what you get to do for homework.